Welcome back, everyone. This week we are going to look at our final method for solving a system of equations. We're going to look at elimination. So take a minute to familiarize yourself with this page, read through everything, and when you are ready, you can continue the video and I'll go through some examples for you. All right, the first example is a fairly straightforward example, and the key thing to look for when we're solving by elimination is opposites. So what we want to look for is either opposite x terms or opposite y terms. And if you look at this set of equations here, you'll notice that we have x's in both equations and then y's in both equations. And well, the x's are both positive, and then the y's, one is positive, one is negative. So there we have our opposites. So we can notice that these two are opposites. So all we have to do to solve this by elimination is add the two equations together. So we're just going to add down. So if we have two positive x's, they become 2x. And then the positive and negative y, they cancel each other out. So they eliminate each other. So we end up with 2x equals 12. And then we can divide by 2. So x is equal to 6. Okay, so once we know one variable, we can go back up and we can plug the x into either one of the equations and solve for y. And I'm going to plug it into the first one because everything is positive in the first one, and I would prefer to deal with positive numbers than the negative numbers. So let's do the first one. But you can do the second one, and you'll end up with the exact same answer. So we have 6 plus y equals 7, so we're going to subtract 6 from both sides. So we end up with y is equal to 1. And just like with every other type of systems of equations problem, we want to write our answer as a point, so we're going to write it as 6, 1. And this one's fairly easy just to look at and confirm that it's correct. So if we look at the first equation, 6 plus 1 equals 7. And then the second one, 6 minus 1 equals 5. So we know for sure that that is the correct answer. Okay, so this one was pretty straightforward because we had opposites in the equation. But if we look at this next example, you'll notice that we have a negative 2x, negative x. Those aren't opposites. We have a positive y, positive 3y. Those are not opposites. So sometimes we have to do a little work before we have opposites, and we have to just multiply one of the equations by something to create opposites. Now, we could multiply the second equation by negative 2, and it would create opposites for the x terms, but I don't really want to have to deal with multiplying by a negative 2. So the other option we have is to multiply the top equation by negative 3. Well, and that one's not much better, so I guess we could pick either one, but let's go with the negative 3 because I think that one might be a little bit easier to do. So I'm just going to multiply this top equation by negative 3. So I'm going to distribute a negative 3 to everything there. So I'm going to have 6x and then negative 3y and then negative 6. Okay, so I can just even get rid of that top equation now if I want to. And my new system of equations is these two right here. And I have opposites in the y term, so if I add down, I end up with negative 1x plus 6x, so that's 5x. And then the y terms cancel each other out, and then both the numbers on the right-hand side are negative, so I can just add them together and keep them negative. And then I can divide by 5, and I get x is equal to negative 2. And so I figured out x is negative 2. Now I can actually go up to any of the three equations up there, even the one that I crossed out. But since I crossed it out, let's just ignore that one. And why don't we plug it into the second original one there. So the negative x plus 3y equals negative 4. So we're going to plug it into that one. Hold on, let me fix that. That's annoying. And so we plug in the negative 2. Well, we have negative 2. So that becomes a positive 2 plus 3y equals negative 4. And so if I subtract 2 from both sides, I have 3y is equal to negative 6. And then if I divide by 3, I get y is -2. So they're both -2, and that's okay because we have a point there, and that's all that we need. And just like the other one, we could plug these numbers into the two equations to figure out if it is the correct solution, and it's often good to do that, but we don't have a whole lot of space here, so I'm just going to assume that -2, -2 is good. All right, in the last example, sometimes we can look at it and not see opposites. So we have 3x and 5x. They're not even close to opposites. 4y and -9y, they're not even close. So sometimes we have to multiply both equations by a number. And what I like to do is just multiply by whatever the coefficient is on the term in the other equation. So I'm just going to focus on the x terms here. And the first equation I'm going to multiply by 5 because I'm getting the 5 from the 5x. So when I multiply 5 times 3x, I'm going to get 15x. And then to get the opposite on the x term in the second equation, I'm going to multiply by, instead of just 3, I'm going to multiply by -3. Then I'll get -15x when I distribute. So if I do the first one, I distribute, I get 15x plus 20y equals, whoops, let me fix that, equals 65. And then the second one, I get -15x, and then plus 27y equals -18. Okay, so we got some bigger numbers that we're dealing with, but it's not too terribly difficult. And so when we add these two equations together, so the x terms cancel each other out, so we end up with 47y equals 65 minus 18 is 47. So this ends up being 1 because we're going to divide by 47. So y is equal to 1. And then to figure out what x is, I have 4 choices. I could plug it into either one of my 2 original equations, or I could plug it into either one of the 2 equations that I created when I multiplied. I'm going to plug it into the first equation because there's no negatives there, and I'd prefer to not have to deal with negatives. So we have 3x plus 4y equals 13. And some of you might think, well, 13 is bigger than 6, but, well, 9 is bigger than 4, and 5 is bigger than 3. So I think either way we're safe in picking the first one, just because there's no negatives in it. So if we plug in that y, we have 3x plus 4 times 1 equals 13. And so we have 3x plus 4 equals 13. Subtract 4. So we have 3x equals 9. And so when we divide by 3, we get x is equal to 3. And so our solution then is 3, 1. And we can do a little quick math here in our heads and say, all right, 3 times 3 is 9, 4 times 1 is 4, so 9 plus 4 is 13. And then 3 times 5 is 15, 9 times 1 is 9, so 15 minus 9 is 6. So we can do that quick math in our head to be able to figure out that the 3, 1 is the correct answer.